I'm recording. Hi, everyone, and welcome to this week's Springboard Office Hours. My name is Ryan Rosario, and I am a mentor for the Data Science Intensive Workshop as well as the Data Science Career Track. And I am also your host for the Data Science Office Hours. With us today, we have a project presentation by David Whitney, and he will be talking to us about some stocks and some stock prediction type work that he's been doing as his capstone project. So how this session works is David will present for about 15 to 20 minutes, and the remaining 10 to 15 minutes will be your chance to ask David any questions you have about anything involving this project. You can ask questions via the chat window on the side. Just type in your question, and we will pick some. We'll probably get through most of them in this 30 minutes. Or you can also raise your hand using the system, and we'll pick on you to get on mic and ask your question verbally. So without further ado, let's all welcome David virtually. And David, take it away.
Thank you so much. I appreciate that, Ryan. So thank you, everybody, for coming. It's a great pleasure to be able to present today. So I worked with Samira Podori over the last couple months, and we had a fun time studying forecasting in the stock market. And my background is in neuroscience, so this was a little bit different for me, but I've always had an interest in finance. And so one of the things that struck me a couple years ago, there we go, was the Wall Street Journal reported that more than half of the NASDAQ's increase in value in 2015 came from 6 companies alone. And so this was added about 664 billion in 2015. But again, it was only 6 stocks. And what were these stocks? These were the so-called FANG stocks. So this is Amazon, Apple, Facebook, Google, Delete, and Netflix. And probably most of them you know, they're household names. And they're called FANG because they were affectionately dubbed by Jim Cramer on Mad Money by that acronym. And I'm going to use that same acronym here. I've added 2 additional stocks, Apple and Delete, since they also contributed quite a bit to the NASDAQ's growth in 2015. And so why was I interested in this? One of the things is that I think we're all very interested in the market. And I was interested in wondering whether or not the increases that we were seeing in the NASDAQ were being primarily driven by these 6 stocks, or was it more distributed across different, say, the larger bulk of the NASDAQ stocks? So in this case, I'm looking only at NASDAQ. I'm not looking at Dow Jones or the S&P 500. But what I'm looking at here was this question of concentration. Is it just a few winners, these FANG stocks, or are we seeing broader recovery in which more than just these FANG stocks are contributing to the growth of the NASDAQ? And so how did I do this? Is using Python, I use the Pandas data reader to connect with Yahoo Finance and download the stock data for all the stocks in the NASDAQ as well as the NASDAQ itself. And then I adjusted the stock prices for all of the data based on any stock splits. And what you're looking at below is in black is the NASDAQ trace for the last 6 years. And on the bottom, we can see different colors. One for, like, say, Apple is in purple. So we can see the different stocks. One of the first things that we can see is that we have a problem of scale. And so one of the first things that we can do is we can look at the relative change from 2011. And we can see a little bit, we're doing a little better here, but not quite right. We can see maybe a little uptick in the NASDAQ, but the lead is really swamping the rest of the stocks. So what I ended up settling on was Z-scoring the data. And here we can clearly see that the NASDAQ has been increasing mostly from 2011 to the end of 2016. And all the other FANG stocks have also been, for the most part, monotonically increasing over the last 6 years. And this might provide some clues of whether or not the FANG stocks are really driving potentially the NASDAQ. But let's see if it's just the FANG stocks. So what I did here is, instead of just looking at the FANG stocks, we can look at the bulk of the other 3,000 stocks that make up the NASDAQ. And so what we have down here, and it's a little complicated, but the lines of the group averages. So in black, we have the NASDAQ, and we can see that it has increased monotonically again over the last 16 years. But what I've done is group averaged the 6 FANG stocks together in red, and that's this dotted red line. And the pink shade is the 95th confidence interval of the FANG stocks. But we can look at more than just the FANG stocks, because we can see that they've been increasing with the NASDAQ, but we can look at other leading NASDAQ stocks. This is the top 100. And we can see that these stocks have also increased over the last 5 years and perhaps plateaued a little bit over the last 2 years. But for the most part, these stocks have also been growing. And so that answers our question that it's not just the FANG stocks that have been growing. But it's worth noting that if we look at the other 2,900 stocks of the NASDAQ, we can see it's mostly flat. That means most of the growth that we've been seeing is concentrated in about 100 or so stocks, but this is just from the group averages. We can look a little closer at individual stocks. So one way that we could do that is you saw that there was an increase in the line. So one way we could look at growth is compute the slope of each of these lines and then do this for each stock. And then what we can do is plot them down here as cumulative probability, where the x-axis is the slope. So positive value would be strong positive growth, whereas a decrease or a decline in the stock value would be indicated by a negative value here. And so the red is the FANG. And so this is the level of the slope. The increase in the FANG stocks was about 0.5. And what we want to do is take a look at the top 100 and other NASDAQ groups and see what percentage of the stocks have a matched growth to these FANG stocks. And what we can see is that about 60% of the top 100 and about 20% of all other NASDAQ stocks have similar growth rates to the FANG stocks. So this is a huge number. We're talking 20% of the NASDAQ. So we're talking about 600 stocks, not just 6. So that's a 100-fold increase than the potential 6 that I had mentioned early on. And it's worth noting that on average, the slope for the FANG and the top 100 are mostly comparable. Granted, for the bulk of the NASDAQ stocks, we certainly weren't seeing much of a change. As we can see here, we in fact saw probably about 50% actually saw a decline in value over the last 6 years. Now, one thing that we can do, because we have so many companies, we can take advantage of clustering analysis, particularly dimension analysis reduction. So we can use k-means clustering, where we can divide up the 3,000 NASDAQ companies into 5 different clusters to reveal some general trends across the stocks. And so one of the important things, so we can see here are the different traces for the different stocks. And it's hard to see, but they're very close as the 95th confidence intervals, which are the shades. So we're doing a pretty good job with actually the clustering. And what we can see is that in cluster 1, we see kind of what was happening with the NASDAQ, this monotonic increase in the value of these stocks. But an important event happened in this data set, and that was in 2011. And that was actually the August 2011 stock market fall, in which we had problems of the European sovereign debt crisis, as well as the downgrading of the U.S. as credit rating from AAA to a AAA rating. And what this caused was a huge stock market fall. And what we can see is actually what happened is that about 30 to 50% of stocks, so 30% of the stocks are in the red. We can see that those increased up, but even those that declined a bit in the orange cluster, which is about 20% of stocks, also started increasing upwards. But the other clusters show kind of a decline and mostly kind of flatlined after that. So what we are kind of have a picture is that overall we've seen some growth in the market, but most of the stocks have stagnated as far as like increasing their value. So it seems like there is a concentration as far as growth in the market. So one of the things before moving on, I wanted to talk a little bit about some of the decisions that I made in analyzing this data, and some of them might be a little controversial, and I'd love to hear some feedback at the end on what you guys think about it. So one of the first things is I didn't include all the NASDAQ data. While there are 3,000 companies, one of the things is the ebbs and flows, which company will be added to the NASDAQ, and say if a company goes out of business, now it's off the NASDAQ. So what do we do with this data set? We could look at all of them, or we could look at, say, stocks that were there the entire time. And what I ended up settling on was making sure that any stock that I considered had to have been a part of the last 6 years, had to be at least 1 full calendar year. So this is 252 trading days. I also looked at 2 other extremes where I required that the stocks had been there all the time, as well as including all of the stocks. And regardless of the way that I analyzed the data, I found that the results didn't change. And perhaps one that, if you think about it, this is probably the most objectionable thing that I did was z-scoring the data. So I took the stock value and I z-scored it. And one might argue that a percent change, which I introduced a little earlier, might be a better way to capture the absolute growth of a company. But the reason that I did the z-score was that it affords us the opportunity to look at the general shape and trend of the growth for each stock. And more importantly, it gives each company an equal vote to the group average. That way we can kind of get a sense, what are the bulk of the stocks doing? So up until this point, I've been mostly doing correlation-based analysis and a little bit of clustering, but now I said, well, could these top stocks be driving the NASDAQ growth? And so we can take advantage of regression to look a little bit at this. And while I 100% admit that regression is not perfect, it's certainly not causal, we can certainly learn a few things, whether or not certain stocks are more likely than others to explain market swings. And so for this analysis, instead of looking at the overall z-score change over time, we're actually going to look at the day-to-day changes in the z-stock scored stock price. So what we're going to do is take the difference from day to day, we're going to end up with a stock trace like this. It looks a mess. And while it might look like a mess, this is actually very informative because we're seeing the day-to-day changes. Are they increasing or decreasing, and do they correlate with the movement of the NASDAQ? And so what we're going to do is set up a regression model in which we're going to try to determine the coefficients at which we can weight our different stocks to try to predict the value of the NASDAQ. And one might question, why do you think that you can do this? And this is because the day-to-day fluctuations in the stocks are usually actually positively correlated with the market movements. And so what you're looking at below is the correlations of the NASDAQ with each stock, and they're computed for the last 24 quarters. And what we're looking at is the average of the 24 quarters. And what we can see is that both FANG and top 100 stocks have a pretty high correlation with the NASDAQ. We can even see pretty strong correlations even with all the other stocks. And you can actually see this with the cumulative probability that even this bulk of the 2,900 stocks, we can see that they're mostly positive correlations. But this actually brings up a real big problem with this data set, and that's the problem of multicollinearity, because while most of these stocks might be correlated with the NASDAQ, that also means they might be correlated with each other. And this is actually a huge problem with the regression. And so I quantified this here. You can see on short time scales of about 1 to 4 weeks, you can actually get pretty high correlations between the FANG and top 100 stocks. And this actually can persist out to even a year. So what did I do? I used ridge regression, so with an L2 norm, and I'll talk a little bit more about this because this was actually a quite involved process because I looked at different regression methods, and ridge regression seemed to be the best one. So because it's computed with an L2 norm, what this does is as you're solving for the regression coefficients, you're actually applying a penalty to large weighted coefficients, so you're not going to get a winner-take-all situation. It allows you to grow the coefficients at an equal rate. And so what we're looking at down below is the average across the 24 quarters and the fits. And what we can see is that overall the FANG stocks, the top 100 stocks, are weighted more highly than the other stocks. But we can even see that there are about 20%, again, of the regular stocks are being weighted as highly as the FANG stocks. So what this is, again, indicating that about 20% of the stocks seem to be having quite a bit of growth, and they seem to be explaining the movements of the NASDAQ. I also used lasso regression and looked at this. This is another popular regularization technique with the L1 norm. And it's popular because you can actually reduce the amount of the data set. So it actually biases you towards getting sparser solutions. So if you have the choice between, say, Apple and Google both explain the movements of the NASDAQ, it'll pick the one that's maybe a little bit better. So say it'll be a winner take all, say Apple will win out. And this gives you a sparser solution. This can be very nice with machine learning predictions, but in this case, I generally had the problem of overfitting. So generally what you see is you can't really predict into the future with market movements because we actually don't know what the the important features are. For example, as I mentioned, that one of the defining features of this data set was the 2011 stock market fall. Well, that was purely driven by sentiment and outside knowledge that one might not have had using this data set. So at least based on the data set that we have here, ridge regression seemed to do the best job, at least predicting that the coefficients that would be most likely to have been predicted based on correlation to have had high coefficient strength did. So in conclusions, what I've shown today is that while 6 stocks, these FANG stocks, have grown substantially and closely vary with the NASDAQ, they aren't behaving fundamentally different than many other NASDAQ stocks. And this includes most of the top 100, but it's really nearly 20% of NASDAQ stocks. And so why do we even care about all of this? Well, the modern portfolio theory tells us that we should want to diversify our portfolio. We don't want to concentrate ourselves in single stocks. Particularly, 5 of the 6 stocks that I mentioned are technology-based stocks. So do you want to be risking your 401k on this? And the answer is probably not. So we want to look at other options where we can diversify ourselves, but also find stocks that will provide us the most growth. And also, kind of I mentioned earlier, one of the questions I had was whether or not this was indicating a robust market recovery or not. And I think we can see that while the FANG stocks are overrepresented in the NASDAQ, the fact that what we're seeing at least 20% of companies showing consistent growth, that is positive signs that the market is recovering robustly. So thank you very much for listening, and I'm happy to open this up for questioning.
Awesome. Great job, David. You did a really, really nice job on the slides. I thought your explanation of these scientific and difficult concepts was pretty good. That's always the most difficult part. I mean, obviously, when I was listening to your conversation before before we started, and you're looking for jobs and whatnot. And of course, there's always that song and dance of going through interviews and whatnot. But any company that hires you should be very happy to have you, because you do a very good job of explaining this stuff and a very good job of displaying it and describing it. So, you know, excellent job.
Most appreciated. Thank you for those kind words.
So we'll open it up to questions. If anybody has a question, go ahead and type it in the box to the right of the screen. You can also raise your hand using the Zoom software, and we'll pick on you. Oh, okay. You're just closing the presentation. Okay, cool. I was like, what was that?
No. I'm still here. I'm okay, trying to.
Yeah. So one thing I should mention is that David was in the intensive course. So if you're here from the foundations course, the requirements for both courses are slightly different. In the intensive course, we focus more on modeling and even more on machine learning and whatnot. Whereas in the foundations course, you're working more with R, learning how to manage data and doing some modeling and data management in R. So if you ever come into these office hours and feel like you're not exactly sure what's being discussed, it's probably you're just in the other class. But we open it up to everybody because this is a good way to learn by osmosis. So I had a couple of, I didn't really have any questions. I thought you did a good job explaining. But I had, well, my first question is kind of random. What are these squiggly green lines at the bottom?
I do not know what those are.
Okay.
I saw them get added on earlier, and I thought maybe it was something automated, so I actually don't know what they are. Okay.
It must just, okay. I thought it was part of your presentation or something. And
yeah, let me stop sharing my screen and try it again. Yeah, I think so, it was.
One of the things that you were talking about was determining whether or not these stocks kind of are the drivers of the NASDAQ or the most descriptive of the NASDAQ. And one thing there's kind of two things here. One is I want to get to that point, but then also you stated that you didn't collect all the stocks, and of course that's reasonable. One thing you could do if you did want to expand this is if you were to collect all the stocks, because everything is so highly correlated, you
Yes.
may want to consider doing a principal components analysis and seeing what's in that first component.
I did that. And so I can actually, so the reason I did ridge regression is actually ridge regression, it has its basis in principal component analysis.
Mm-hmm.
And what I found was that the only component that mattered so I started actually with principal component regression.
Yeah.
And so I looked at it, and the first component explained almost all of the data.
Yeah.
In this case, because it was so highly correlated, you don't normally have that. But if you remove that first principal component, you do terrible explaining the data.
And
so,
were these 6 stocks in that first component?
Yes, they were.
Awesome.
So I didn't include it for sake of brevity, but like even the key means clustering, the FANG and top 100 stocks tend to always be in the cluster or principal component that you were expecting.
Mm-hmm. Mm-hmm. Yeah, awesome. I mean, I learned something today. I mean, I'm sort of familiar with ridge regression. I don't use it a whole lot. I didn't know it had a backing in PCA. So
yeah, actually, if you solve it, it is actually PCA.
Wow.
In certain instances. So I didn't know that until late in the game, and I'm like, oh, that's why ridge regression is so popular.
Yeah, it always blows my mind when I learn things from mentees. It's great. That's why we're here. So keep up the great work and keep up the enthusiasm. I want to get to Jorge, and then if nobody else asks questions, I have a couple more comments. Jorge asks, is your code available on GitHub or somewhere?
Yes, it is. So I'd be happy to post a link to that.
Awesome. You can go into the community under the okay, perfect. You can post it here, or you can go into the community event, and I believe you can add a comment there, and you can put the link there.
Okay, sure. I can see if I can add it now, or I can. And it doesn't have the most up-to-date version of the code, but I will. Which would you prefer for as far as like? Would you prefer? Well, I can do both places.
Oh, I think both is fine. I mean, here, anybody who's on the call can see it.
Yes.
And they're probably going to the link right now. But anybody who is watching this video later, it might help to put it in the event. That way they can refer to it.
Yeah, well, and it also has some of my some of the other stuffs, like the mini projects that I did. So it has all my exercises and everything on it. But the capstone project data is in on that link.
Perfect. Anyone else have any questions? There's someone clicking. Is someone trying to talk?
Oh, I think it might have been me.
Okay. Okay, so I had one other comment. You use z-scores, which is pretty common.
Yes.
And as you probably know, z-scores are really only the most appropriate when you have a normal distribution, or maybe even a symmetric distribution might be okay.
Yes.
I don't really balk when people use them if the distribution is not normal, as long as you have a good reason to use them, and I think you did. But another thing you could try, in case anybody did give you an issue, is quantiles instead of z-scores.
Yes, I have done that before, where you rank the data. So the rank order data, and that can help. Like I almost never use, I almost always use rank order. The reason I did z-score was because I did a lot of correlations, and if you ever compute a correlation, you are doing a z-score essentially. And so I thought it was a straightforward way to describe the data. I agree with you that I think that's worthwhile thinking. Can you? I guess if you did the rankings, you could do Spearman rather than Pearson's correlation coefficient. So I guess, okay, yeah, that may be not a bad one. Idea.
Yeah, I mean, either way, I mean, z-scores are perfectly fine. I just always add that disclaimer in there because somebody who took basic stats might say something, and sometimes we violate the rules of basic stats, and it's okay.
Well, exactly. I'm a neuroscientist, so we deal with it all the time. We just do non-parametric tests all the time because in my field, everybody's like, no, can't use parametric unless you prove it. And we're like, okay, fine, we'll just use non-parametric.
Yeah, like for example, a lot of people will try to use linear regression, but it violates the assumptions of linear regression, but it still predicts well. And as a statistician, I might say something, you shouldn't do that, but really the goal is prediction. So as long as it accomplishes the goal, I usually won't complain too much. Now, O'Brien has a question. I've taken the fundamentals course, but I wonder how much did you know about statistical modeling before this course? In other words, did this course give you this depth of understanding of statistics?
So the answer is I actually had a lot because of my doctoral training. So just a little bit about me. I enjoy programming in Python and MATLAB, but my background, so I got my PhD a couple years ago in systems neuroscience. And there, to understand the kind of complicated problems that we have there, we have to have a strong grounding in statistics. But I never actually took a course in it. It's just something that I picked up over the years.
Wow. That's pretty good. And for everyone, listening, always, be learning more and learn how to learn. One of the things about a PhD that's always said is that you learn how to learn. Of course, I mean, if you don't have to have a PhD to show you know how to learn, obviously.
Absolutely.
Whenever people are complaining, like, why am I doing a PhD in linguistics? Like, you're here to learn how to learn, not necessarily because you're going to work in linguistics. But anyway.
Exactly. Well, I mean, most of the stuff that I learned, I'm probably not going to use, but my hope is just like we are to use most of the stuff in your BS. The answer is probably not, but it does give you a grounding. And so I do think it is a good grounding. Certainly was long, so I'm actually looking forward to actually move into industry.
Yeah. Oh, definitely. I took some time off my PhD to work in industry, and I don't regret it at all. I feel much more employable now.
Oh, good. So what's your background, Ryan?
Statistics.
Statistics.
But I got I'm actually more computer science than statistics. I did a master's in CS, so I went and worked in that, and worked in Silicon Valley, and then came back to finish my PhD. And I feel like that kind of well-rounded my education. Some people's programs are great and everything goes well, and
right.
You're right off the bat ready to go. My advisor and I didn't have the same research area, so going to industry really trained me well for data science, as opposed to just getting a PhD and not having any clue what I was doing. Are you in that boat?
No. Well, I have a PhD. Not that I don't know. I know what I like. I realized that I ended up like analyzing the data, and so this started becoming my passion. Where statistics, the machine learning, all of that. I realized it was liking analyzing data more than collecting data. So this is partly why I was making the decision. Maybe I'll go into industry where they'll pay me to analyze data.
Yeah.
So
as long as you and your advisor share the same field, it's great. In my case, I would have graduated and had no idea. So that's why I went to work. But most people don't have that situation. Right.
And well, I'm hoping I'll have the same success that you've had.
I'm sure you will. I don't doubt that one bit. Anybody have any questions? We are almost through for the evening. So speak now or forever hold your peace. Raise your hand, type a comment really quickly or question. Okay. Well, if not, thank you everybody for coming. Thank you, David, for a great presentation, and best of luck to you in your job search. I'm sure you'll be successful. And have a great weekend, everybody, and we'll see you all next week.
Awesome. Thanks, everyone.
Thank you.